Okay, this is 6.4, Law of Sines, and I've already written out my formulas. Remember, you've got the angle, sine of the angle over the side is equal to the sine of the angle B over your side is equal to the sine of angle C over your side. Remember, you can flip all of this and it's still equivalent. And these are just like proportions. Okay, so the only time that you can use law of sines is when you have two angles plus an included side, and this is angle, side angle. Another time that you can use this is when you have two angles plus one side, and this would be angle, angle, side. This is the only time that you can use law of sines. Okay, so let's do an example. So if I were to be given a random triangle labeled A, B, and C, where your side C is 340, angle A is 75 degrees, angle B is 60 degrees. And how about I say let's just find angle or side B. Okay, the first thing I want to know is this triangle unique? Meaning, is there any other triangle like this? And I would say yes, this is unique by reason angle, side angle. Okay? And since this is one of the reasons that we can use law of sines, the first thing that I want to go ahead and do is find the measure of angle C. And this is really easy to do. To find the measure of angle C, I can just go ahead and do 180 minus 75 and 60. So go ahead and combine those two, and the measure of angle C would be 45 degrees. I can go ahead and find B, find side B. So I'm going to go ahead and pick this side right here, and you can pick any other side, but since I've got side C, I'm going to have to use this. So I'm going to do sine B and sine C. So that would be sine of 45 degrees over its side, which is 340, is equal to sine of 60 degrees over its equivalent side, which is a B. You're going to cross multiply, making sure that you put this number in front because it's like the coefficient. To get B by itself, I'm going to divide. Now I can plug this straight into my calculator, making sure you're using parentheses around the top and the bottom. And I get a measurement of 416,413. And that is my side measurement. Remember, let's do this first, that a unique triangle is formed by angle, side angle, by angle, angle, side, by side, angle, side, and by side, side, side. These first two, you can use law of sines, which we are doing today. And these last two we used yesterday, which are the law of cosines. If you remember way back when, in geometry, that side-side angle is not a postulate. Therefore, it is not, you do not form a triangle. Okay? This is called an ambiguous case. This is an unclear, and that you could have more than one solution to it. And this is what I mean by an ambiguous case. If I were to have, suppose I have 15 on this leg and I have 26 on this leg. I don't even know what this angle could be, an angle degree. Okay, so side, side, and angle. This angle degree right here could be a number of things. This angle could be, with this 15 and this 26, I could have this angle degree be it could go up and meet this leg right here. If it did, then I have one solution, which is perfect. This is what I want to happen. Or I could have this same triangle with 15 and 26. What if this same degree, what if that same leg measurement could meet right there, and it could meet right there as well? If that's the case and this leg met in two different places, that could be two solutions. In that case, you're going to have to do a lot of work in order to meet that leg in two different places. And I know you don't want to do that. Also, another possibility is, what if that leg of measurement doesn't quite meet? And in this case, this would be a no solution. You had a triangle. Let's draw another random triangle. Let's label it ABC. And what if I use these numbers, 15, 26, and let's do an a side angle. Therefore, you know this is an ambiguous case. And I'm going to try the law of sines on this. So that means I'm going to do side angle C over the side. So that would be sine of 29 degrees over its opposite side, which is 15. And this is what a lot of people try to do. Since I have this side, I'm going to say sine of angle A over its opposite side, which is 26. Cross multiply. That's going to give me 15 of sine A. And then that gives me 26 of sine 29 degrees. So if I were to solve, giving me an arc cosine, that gives me the measure of angle A is 57.176 degrees. Let's look at this. So we're saying that angle A is positive, right? So sine is positive here and here. So that means that sine can build a triangle here, or it can build a triangle here. The angle can fall here or here. So that means right now we've got two possibilities, which on the previous page there can be two solutions. This is a two solution problem. So that means that 57 degrees is here, or it looks like I can say 180 minus that. It looks like the measure of angle A could also be 122.824 degrees. Most of the time, people do not check to see if there's another solution. That's why I always say do not use sine on ambiguous cases. Therefore, don't use them unless you are working with angle side angle and angle side problems. Okay? Also, if you were to find, so that is angle A, now in order to find angle B, you're also going to have to subtract for this one and this one to find the other solutions. The better way is to use the law of cosines. I would start with a 15 squared. You don't have a b, which is okay. So 15 squared plus b squared plus 26 squared minus 2 times your b value times 26 cosine of 29 degrees. Okay, I would move my 15 over. So that's 0 equals b squared 26 squared minus 2b 26 cosine of 29 degrees minus 15 squared. Now, what I can do is plug this in to y2, this into y1, and find the intersection. How easy is that? And I had to do no work at all. Okay? And there wasn't any room for a mess up. So here I would find the intersection. Find intersection in calculator. All right. And I will go ahead and tell you those answers. I found the intersection in the calculator, therefore I've got, let's see, I've got B. So how about we say B is equal to 14.609. Looks like I have two answers, and that is 30.871. Drawing my random triangle that I keep drawing. Here's A, B, and C. Let's see, let's make this 45 degrees. 7, let's make this 10, and let's make this C. So it looks like I have a side-side angle. So always look at your angle that's across from your side. So this is where I'm going to start. So I'm going to start with 10 squared is equal to 7 squared plus C squared minus 2 times 7 times C and cosine of 45 degrees. And I like to use cosine because there's not going to be any reason why I should make a mistake on this. Okay, so I'm going to move this over like I did in the problem before, so I can set it equal to 0. So that 0 equals 7 squared and C squared minus 2 times 7 times C cosine of 45 degrees, and this is going to be minus 100 or 10 squared. All right, now what I'm going to do is plug this into the calculator. So this is going to be y1 or y2, and this is y2, and I'm going to find the intersection of these two numbers. So this is 0 in the left side, the right side. So I'm going to solve for C. It looks like I have a parabola. So one of them is going to be an intersection of 13.639. The other one looks like it's on the left side, so it's a negative value. And this doesn't make sense because we're talking about the length of a triangle. So I'm going to cross this out and say that this is the length of my triangle, 13.639. Okay, so that would be the length of C. If I wanted to go ahead and find angle B and angle C, I could finish that with the law of cosines. Try our crazy triangle again, A, B, and C. Let's use side B as 122. Let's use side A as 70. Let's try this as 42 degrees, and this as C. All right, so it looks like we have, again, a side-side angle. So again, this is an ambiguous case. So I'm going to set up law of cosines again. This is the side I'm going to use because this is the angle I'm given. So I'm starting with A squared. So this would be 70 squared is equal to 122 squared plus C squared minus 2 times 122 times C, and that would be times cosine of 42 degrees. Again, I'm going to solve for 0, so 0 is equal to 122 squared plus C squared minus, and I don't ever start multiplying because then you start messing up things when you do, times the C, put that in parentheses, cosine of 42 degrees, and then I'm going to subtract the 70 squared. Okay, so this is y1, and this is y2. And it looks like no matter what we do, that we're not touching the x-axis, so therefore we have no roots. So therefore C has no solution. So if we were to draw a picture, basically C right here wouldn't touch at all. So no solution. So this triangle is not possible. And that would be my answer. Okay, make sure you bring questions to class.